want to look at a couple of limiting cases here. We want to take the limit for an impedance as the frequency gets very high, and we want to take the limit of the impedance at the frequency gets very low. Now, why this turns out to be actually not very hard to do, because we know that if we look at a capacitor, so if we have a capacitor or an inductor, then if we look at the reactive capacitance and the inductive capacitance, then at high frequency, then that goes to zero. In other words, at very high frequencies, capacitors act like wires, and at low frequencies, it goes to infinity. In other words, it acts like a break in the circuit. You know, where on the other hand, for the inductive, or rather the inductive reactance at high frequencies, then at high frequencies, then it acts like a break in the circuit, so it goes to infinity. And then at low frequencies, then it tends to act like just a wire. Okay, so what would that mean? Okay, well, let's consider several cases here. Okay, so let's consider that we have right here, okay, so we have a resistor, we have a capacitor, we have an inductor, we have another resistor, we have a resistor, like that. So let's say that this is 100 ohms, and this one right here is 100 ohms, and this one over here is 100 ohms. Okay, that's an inductor, that's a capacitor. It doesn't really matter what the inductor and capacitor is, as long as there's something reasonable, not super high or super low. If they're super high or super low, what I'm about to say doesn't really hold as readily. So at low frequencies, so if for low frequencies, then that means that the capacitor is going to act basically like an open circuit. So it's going to act like it's broken right there. And the inductor is just going to act like a wire. And so that means that we have two 100 ohm resistors in parallel. So what's 200 ohm resistors in parallel? Well, that is going to be 50 ohms. And that 50 ohms is going to be in series with 100 ohms. So that means that the total impedance is going to be about 150 ohms. Okay, now we want to go for high frequencies. So for high frequencies, the capacitor acts like a wire, and the inductor acts like a break in the circuit. Okay, and so that means we have 200 ohms right here in parallel with 100 ohms. So if you work that out, 200 ohms in parallel with 100 ohms is going to be 67 ohms. And so those are our limiting cases right there. All right, and remember, the original circuit was an inductor and a capacitor right there. And so all we did was we approximated for high and low frequencies what was going to happen. Okay. Now, what's high and low frequencies? Well, that depends on what the inductance is. It depends on what the capacitance is. So high and low for one circuit might not be exactly high and low for the other circuit. But very high, very low will still have this basic behavior right there. So another circuit right here. Let's say that we again have a frequency source right here. We have a resistor, we have an inductor, we have a resistor, we have a capacitor. And then these are connected up to a resistor and a capacitor. And then all that connects back to here. And let's say this is 100 ohms. That's 200 ohms. And the resistor on the right here is going to be 150 ohms. Okay, so I want to know for low frequency, what's the impedance going to be like? And for high frequency, what's the impedance going to be like? Okay, for low frequency, then the capacitor acts like a break in the circuit. So that means no current flows through that 100 ohm resistor. Acts like a break in the circuit right there. And so what happens is the inductor acts like a wire. So it looks like that we just have current flowing across the top up here. And so it goes right through the 200 ohms and the 150 ohms. So that's 200 in series with 150. So the impedance will go to 350 ohms. Now, for high frequency, what's going to happen? Well, that means this is going to act like a wire right there, and it's going to act like a wire for the other capacitor. It's going to be a break in the circuit right there. So nothing goes through the 200 ohm resistor. So current goes through the 100 ohm, but when it gets over here, notice this is zero resistance right here. So the current's going to want to go this way, and that's basically shorting out that 150 ohm resistor. You don't even see it because the current's going to go through just the wire. And so that means all that you see, all that the current sees is that 100 ohms right there. And so that goes to 100 ohms. Okay. All right. Let's do another example. Okay. So we have a power supply right here, and it comes up here, and we have a three-way split. On the top, it is a resistor and a capacitor. Okay. And then we have another capacitor right there. In the middle, we have an inductor, and it connects up right there. And on the bottom, we have a resistor, an inductor right there. And then we have a resistor right there and a resistor right there. And then all of these things come together over here, and they go back to the power supply. So let's say that each resistor is 100 ohms. Okay, so we have inductor, capacitor. And so I want to know, again, for low frequencies and for high frequencies, what's the limiting cases here? Okay, so for low frequencies, then the capacitor acts like a break in the circuit. So it acts like there's a break in the circuit and a break in the circuit there. Okay, for low frequencies, the inductor acts like a wire. So these are all wires here, and this wire here completely shorts out that 100 ohm resistor, so you don't even see that 100 ohm resistor. All you see are the other two resistors in parallel. Okay, so 200 ohm resistors in parallel gives you impedance of 50 ohms. Okay, now for high frequencies, then what happens is we've got the capacitors here, and the capacitors act like wires, and these act like breaks in the circuit right there. So the current here doesn't go through here. It can't go through there, so it only goes through here. And this capacitor right here shorts out all of those right there. And so the current just goes straight back. And so the only thing it sees is that one resistor right there. So that goes to 100 ohms. Okay. If the second capacitor were not there, then it'd be 150 ohms because it would have gone through here. And well, no, it would have been 200 ohms. So if the other capacitor had not been there, then this inductor would have kept that one out of the loop, and so current would have gone that way, and it would have been 200 ohms if that capacitor had not been there. Okay, so we have three examples here of limiting cases for these sorts of things. And so hopefully that helps out a little bit.